welcome back. This is the Easa PART-66 Mod 2 Physics, and as part of the physics we have sub-modules like kinetics, and these questions are for kinetics only. But during the exams we have 56 questions which comprises of various topics and various modules, but these questions are solely based on kinetics. So let's get straight into it. Question 51 says a vehicle travels 6 kilometers in 10 minutes. Its average speed is. So you have been given the distance, you have been given the time. So distance, apologies for my pen. Alright, I need a black pen here. Yeah, that's it. So you've been given the distance, you've been given the time. Average speed equals distance over time. So your distance equals 6 kilometers. And the time t equals 10 minutes. Now let's take a quick look at the options that we've been given. The answers are in meters per second. So we have to convert our distance into meters and our time into seconds. So now we have speed, which equals distance over time. So our distance is 6 kilometers, which is 6,000 meters. 6,000 meters divided by time, which is 10 minutes. We convert 10 minutes into seconds. That is going to be 10 times 60 seconds. So 6,000 meters divided by 600. Alright, that is going to give you 10 meters per second. So that is the average speed. If you travel 6 kilometers in 10 minutes, the average speed, this is straightforward. You have to list the parameters down, what has been given. You have the distance, you have the time. You put down the formula, the suitable formula. So speed equals distance over time. Our speed is 6,000 meters. Our time is 600 seconds. When you divide it, you're going to get 10 meters per second. That is the right answer. Number 52 says the acceleration of a body which moves with a simple harmonic motion is maximum when its displacement is 0. That is the right answer. Question number 53. The landing speed of an aircraft is 54 meters per second. If the maximum deceleration is 3 meters per second squared, the minimum length of the runway required is. Now let's list the parameters. So we have velocity equals 54 meters per second. That's the final velocity, the initial velocity, because it started from rest, although it didn't state in this question. 0 meters per second. You have acceleration or deceleration here is 3 meters per second squared, and you're looking for the distance. So looking at the parameters, you're going to use the formula v squared equals u squared plus 2s. If you make s the subject, you're going to get v squared minus u squared divided by 2a. That is going to give you 54 squared divided by 2 into 3. So 54 squared can be written as 54 times 54 divided by 6. That will give you, when you cancel 6 there, that will give you 9. So 9 times 54. With straight multiplication, you are going to get 486 meters. That is the right answer. Let's go back to question number 54. In a gear train, the driver has 100 teeth and the driven has 50 teeth. So T driver equals 100. T to the driven equals 50. The driven rotates twice as fast. The driver and the driven rotate at the same speed. The driven rotates half as fast. In order to find the answer for this question, you have to put down the gear ratio. So if you have the gear ratio equals driven over driver, and we have the driven to be 50, the driver is 100. You can cancel it out to be 1 over 2, which equals driven over driver. When you cross multiply, you're going to get driver equals 2 times driven. So the driven rotates twice as fast. Question 55. A wind drum is used to lift a 60 kilogram force load by application of a 20 kilogram force effort. The crank handle is 44 centimeters and the drum is 11 centimeters radius. What is the efficiency of the windlass? In order to solve questions like this, you need to state the parameters, find a suitable formula, plug in the numbers or the figures. So now we have the load. Equals 60 kilogram force, and we have the effort equals 20 kilogram force. Now the load distance, let's make it DL, equals 11 centimeters. And the effort distance, or DE, equals 44 centimeters. Now the efficiency equals mechanical advantage over velocity ratio. If we find a mechanical advantage, which equals load over effort, that is going to be 60 divided by 20. That will give you 3. Velocity ratio equals effort distance, DE, over load distance, DL. That is 44 divided by 11. 44 divided by 11 is going to give you 4. So therefore, efficiency equals mechanical advantage over velocity ratio. Mechanical advantage is 3. Velocity ratio is 4. Now, when you look through the options or the answers given, it's in percentages. So we need to multiply by 100 times 100. That is going to give you 3 times 25, which equals 75%. Alright, feel free to pause the video and solve the question. Question number 56. A cyclist goes from rest to 50 meters per second in 5 seconds. What is the average acceleration? When you go from rest, your initial velocity u equals 0 meters per second. The final velocity v equals 50 meters per second. Time t is 5 seconds. Acceleration is not given. So when you look at these parameters, you're going to use the formula v equals u plus at. You make a subject v minus u divided by t. Your v is 50. Your u is 0 divided by 5. That's going to give you 50 divided by 5, which is 10 meters per second squared. That is acceleration, so that is the answer. Which of the following is not an equation of motion? V equals u plus at is an equation of motion. S equals ut plus half at squared is an equation of motion. This is not. Number 58. A body drops from 10 meters. That is the height. It will hit the ground in, the options given are 2 seconds, root 2 seconds, and 1 second. So let's try and work this one out. Number 58. So you have the distance s equals, distance s equals 10 meters. Time is not given. We're looking for time. We assume acceleration equals 10 meters per second squared. Initial velocity equals 0 meters per second because it was dropped from a height. So the formula we are going to use is S equals ut plus at squared over 2. You can plug in the values directly to make it easier. So you have 10 equals 0t plus 10t squared over 2. So we are going to have 10 equals 5t squared. T squared equals 10 over 5. So this is going to give you t squared equals 2. Therefore, t equals root 2. That is the answer, root 2 seconds. Number 59. A winding drum has a crank handle of radius 33 centimeters and a drum of radius 11 centimeters. What is the velocity ratio? The velocity ratio here, velocity ratio equals effort distance dE over load distance. And you have been given the effort distance to be 33 and the load distance to be 11. 33 divided by 11. That is going to give you 3 centimeters. Question number 60. Resonance is a phenomenon whereby the external excitation frequency equals the natural frequency. That is the answer. The area under a graph velocity, the area under a velocity time graph represents distance traveled. Alright, number 62 says the frequency of a pendulum that completes one cycle in 4 milliseconds. So you have frequency equals cycle over time. So you have 1 divided by 4 milliseconds. That will give you 1/4 times 10 minus 3 seconds. Alright, 10 minus 3 can be written as 1000 divided by 4, which is going to give you 250 hertz. 250 hertz. 63. A pendulum in simple harmonic motion has a frequency of 4 hertz. Its period will be, so frequency F is the inverse of period, 1/t. That was going to give you 1 divided by 4 seconds. When an oscillating system produces a sinusoidal pattern, it is said that the system is undergoing what type of motion? Harmonic motion. A wave whose frequency is an integral whole number multiples of the frequency of some reference wave is said to be a harmonic frequency. A belt driving a pulley is traveling at a velocity 6 meters per second. The pulley is traveling at 8 rods per second. What is the diameter of the pulley? So you have the linear velocity v equals 6 meters per second. The angular velocity equals 8 rods per second. What is the diameter d? So we know linear velocity equals angular velocity times the radius. So you have 6 equals 8r. R equals 6/8. That is going to give you the radius. So the diameter d equals 2r. That would give you 6/8 times 2. That is 12/8. That is the right answer. Work done is measured in. Work done equals force times distance. Force is measured in newtons, distance in meters. So Newton meters in joules. Newton meters in joules. Alright, let's continue to question 68. Force equals mass times acceleration. It's an equation which expresses Newton's second law. Question number 69. An aircraft weighing 6,400 pounds lands at a speed of 10 feet per second and stops in 10 seconds. What force was generated by the brakes, assuming gravity as 32 feet per second squared? So in this question, the aircraft lands with a kinetic energy. Okay, it's giving you the initial velocity, and the final velocity is 0 feet per second because it stopped. So the final velocity is 0. The initial velocity is 10. So let's list down the parameters. We have the weight of the aircraft. That is not the mass, it's the weight of the aircraft. Take note of weight. That is the weight of the aircraft, W. equals 6,400 pounds force, or pounds. It lands at a speed of 10 feet per second. That's the initial velocity. U equals 10 feet per second. And the final velocity, because it stopped, equals 0 feet per second. So it's asking for the force. So the time it takes to stop t equals 10 seconds. And it's asking for the force. So now force equals mass times acceleration. The force equals mass times acceleration. But we need to find the mass of the aircraft. That is going to give you weight equals mg. So mass equals weight over g. That is 6,400 divided by 32. It's going to give you the mass. So therefore mass equals 200 slugs. 200 slugs. So now we've got the mass. We need to find acceleration. Acceleration equals changing velocity over time. So the changing velocity, final minus u divided by t. That is 0 minus 10 divided by 10. Therefore, acceleration is going to give you minus 1 feet per second squared. So straight away you can find the force. Force equals mass times acceleration. Braking force equals mass, which is 200 slugs, times minus 1. That is going to give you minus 200 lbs, pounds force. So that is the correct answer. Question number 70. A scalar quantity is one which possesses, it's a scalar quantity, magnitude only. Sometimes they'll give you what is a vector quantity. It has magnitude and direction. So if you have a scalar quantity, it has magnitude only. Magnitude. And a vector quantity, take note, that is magnitude and direction. That 7,100 meters is approximately how many yards? So we know 1 meter equals 3.3 feet. Therefore 100 meters equals 330 feet. 3 feet, you know 3 feet equals 1 yard. So therefore 330 divided by 3, that is going to give you 110 yards. Yeah, so we have 110 yards. That corresponds to 109. So 100 meters, so approximately 109 yards. Right, let's go straight into 72. A mass on a spring nearly hits the ground 20 times a minute. Its frequency is frequency F, cause number of cycles over time. So we have 20 over 60. So it's 1 minute, that's 60 seconds. That would be 1 over 3 cycle per second. (76) When a pendulum is swinging freely, it is accelerating towards the outer point of the swing, not accelerating at any point, accelerating towards the center of the swing. That is the right answer. 74. A velocity of 36 kilometers per hour is equivalent to, when you look at the options, always when there is a conversion, take a look at the answers given and take a critical look at the units as well. So these units are given in meters per second. So whatever you have as a parameter, you have to convert it into meters per second. So 36 kilometers per hour is equivalent to, so you have 36 kilometers per hour is equivalent to what meters per second? So we are going to convert 36 kilometers to meters. That will be 36,000 meters. And hour to seconds. So 1 hour equals 3,600 seconds. 3,600 seconds. When you divide, this is going to give you 10 meters per second. Alternatively, you can just go straight away. 36 kilometers per hour divided by 3.6. You are going to get 10 meters per second. Question number 75. An aircraft of 2 metric tons lands with 400 kilojoules of energy. 10 kilonewtons of force is applied at the brakes. How far does the aircraft take a stop? So with this type of questions, we are going to use work done kinetic energy theorem or work energy theorem. So work energy theorem. Work energy theorem. That says change in kinetic energy equals work done. That is force times distance. So the aircraft lands with a kinetic energy of 400 kilojoules of energy. So that is the initial. And the final, because it came to a stop, the final kinetic energy equals 0. So 400 kilojoules of energy. 400 kilojoules minus 0 kilojoules equals, you've been given a force as 10 kilonewtons. 10 kilonewtons. 10 kilonewtons times distance. So distance equals 400 kilojoules divided by 10 kilonewtons. That is 4,000 joules, 400,000 joules divided by 10,000 newtons. That's going to give you 40 meters. That is the right answer. Which of Newton's law apply mostly to an aircraft which is accelerating down a runway? When you hear the word acceleration, always go for the second law. That is force equals mass times acceleration. 77. An object is undergoing simple harmonic motion with a frequency of 4 Hz. What is a period? Period is the inverse of frequency. So 1 divided by 4 equals 0.25 seconds. The number of radians in a circle 360 degrees is 360 degrees equals 2 pi radian. That is also equals 1 revolution. Take note just in case some of the questions they might ask you for the revolution, and sometimes in mails as well. So that is 2 pi. An aircraft starts at rest. Initial velocity equals 0 meters per second. At the end of a 3,000 meter runway, it accelerates at a rate of 20 meters per second squared. If the takeoff speed is 200 meters per second, it will take off at a 2,000 meter marker, run off the end of the runway, take off at the 1,000 meter marker. So this question is trying to get the distance it covered before the aircraft took off. So now from the question we have acceleration A equals 20 meters per second squared. We don't know the distance that it took off. We have the speed, that's the final velocity, V equals 200 meters per second. Because it started from rest, initial velocity equals 0 meters per second. So from the parameters given, we could use the formula V squared equals U squared plus 2AS. Making S the subject, you're gonna get 2 squared minus U squared divided by 2A. So S equals 200 squared divided by 2 into 20. That is 40,000 divided by 40, which will give you 1,000 meters. So that is the point that the aircraft took off. Take off at 1,000 meters marker. Mechanical advantage is MA. So it's load over effort. Right, so question number 81. A spaceship travels a distance of 480,000 miles in 2 days. What is its speed? We already know speed equals distance over time. And the distance is giving us 480,000 miles. But remember, it's in mile per hour, so you convert the 2 days to hours. If you have 1 day equals 24 hours, 2 days will be 48 hours. So time is 48 hours. So when you divide 480,000 miles by 48 hours, you're going to get 10,000 miles. 10,000 miles per hour. Well, that is it. Let's jump into question number 82. A light aircraft flies in a semicircle from point A to B. If the circle has a radius of 20 kilometers and the time taken is 30 minutes, the average speed is. So that is a circle. Yeah, and we know that the circumference of a circle, C, equals 2 pi r. But this is a semicircle. That will be 2 pi r divided by 2. That is going to give us pi r. So pi r is a distance, let's say A and B. Pi r is a distance the aircraft covers. That will be from point A till point B, not drawn to scale. So distance equals pi r. And the time given, time t, equals 30 minutes. 30 minutes converted into hours will be 0.5 hours. But speed equals distance over time. So the distance will give us 20 pi, because the radius is 20 kilometers, 20 pi kilometers divided by 0.5. Twenty pi kilometers divided by 0.5 can be written as 2 pi times 10 kilometers. We are extracting 2 pi because we know the value of 2 pi to be approximately 6. Since we are not using calculators, if you have a calculator, you can work it straight away and get the answer, but we don't have a calculator, so we have to try and do some approximations here. So we have 2 pi times 10 divided by 0.5. That is going to give us 6 times 10, which is 60, divided by 0.5. That will be 120 kilometers per hour. When you look into the options given, 125.7 is the closest possible value, so that is the answer. 83. A drive shaft has a speed 150 pi radians a second. What is the speed in RPM? So when you're converting radians per second to RPM, you multiply by 60 divided by 2 pi. So we have 150 pi radian per second times 60 divided by 2 pi. So 150 pi times 60 divided by 2 pi. 2 pi goes into 150 pi, that's 75. So you're going to get 75 times 60, which will give you 4,500 RPM. That is it. 84. Question 84. A machine requires an effort of 40 newtons to raise an object of 50 kilograms. If the object is raised 30 millimeters when the effort moves a distance of 540 millimeters, assuming acceleration due to gravity is 10 meters per second squared, what is the velocity ratio? Velocity ratio equals effort distance divided by load distance. Although there are a lot of parameters given or some values given, but you are not going to use it in this instance. You have the effort distance, we have the load distance. The effort distance is 540 millimeters divided by the load distance was given as 30 millimeters. When you divide 450 by 30, you are going to get 18 millimeters. That is 18 millimeters. 85. Resonance is a term applied to oscillatory motion or vibration. Movement in a circle, movement in a straight line, oscillatory motion or vibration, that is resonance. '86. Resonance is said to occur when a body vibrates under elastic or restoring forces, oscillates as its own natural frequency, is forced to vibrate by contact with another natural frequency. The SI unit of velocity is the velocity meters per second. Is a meter per second squared? No, that's meter per second. Question number 88. This question we've solved it before and it looks quite familiar, I think. A spring with a load on the end hangs down to a height of 10 centimeters above the ground and returns to a height of 24 centimeters above the ground. What is the amplitude of the movement? So basically the amplitude is the distance traveled by the oscillation or the oscillatory distance divided by 2. So we're going to have 24 minus 10 divided by 2. That will give us 14 divided by 2. That will give us 7 centimeters. Question 89. The oscillation produced by a pendulum 2,500 millimeters long has a periodic time of, you need to put down the formula for period before you can substitute the value. So T period equals 2 pi times the root of the length divided by acceleration due to gravity. So the length has been given us 2,500 millimeters. You have to convert it into meters. 1, 2, 3. That's going to be 2.5 meters. Acceleration due to gravity is not given specifically, so you take it as 10 meters per second squared. So T equals 2 pi times the root of 2.5 divided by 10. That will give you 2 pi times the root 0.5 0.25. That will give you, we know 2 pi equals 6. Always take note 2 pi equals 6. So 6 times the root of 0.25 will give you 0.5. That is 0.5, which equals 3. That is the answer. Right, let's get straight into question number 90. The linear equations of motion rely for their derivation on one very important fact, which is that acceleration is assumed to be constant. 91. Calculate the acceleration produced when a force of 75 newtons acts on a mass of 150 kilograms. So the force is given as 75 newtons and the mass is given as 150 kilogram. Straight work. Force equals mass times acceleration. Making acceleration the subject, F over m. That is going to give you 75 over 150. 75 divided by 150, that will give you 1 over 2, which is 0.5 meters per second squared acceleration. Right, question number 92. If a body starts at rest, initial velocity equals 0. That's what it means. Reaches 84 meters per second. That's the final velocity in 3 seconds. Its acceleration is acceleration. So you've been given initial velocity equals 0 meters per second. Final velocity 84 meters per second. And the time equals 3 seconds. Acceleration is called change in velocity over time. Acceleration equals 84 minus 0 divided by 3. Acceleration equals 84 divided by 3, which is going to give you, that will give you 28 meters per second squared. Right, question number 93. For a car weighing 1000 newtons, what force would be required to accelerate the car to 3 meters per second squared? So the weight was given as 1000 newtons. Acceleration was given as 3 meters per second squared. But the weight of the car, we need to find the mass of the car. So weight W equals mass times acceleration due to gravity. So 1000 equals the mass times 10. Okay. Normally, they're going to use 9.81, but for the purpose of our calculations, we need to have some estimation. So we're going to use 10. So the mass is going to be 1000 divided by 10. That will give you 100 kilogram. And now the force equals the mass times acceleration. Force equals, we have the mass to be 100 kilogram. Acceleration is 3 meters per second squared. That is going to give us 300 newtons. And right here, that is the closest value. So that is our answer. Let's get straight into question number 95. For every action, there is an equal and opposite reaction. This is known as Newton's third law. 96. If an object is in a state of inertia, if it begins either at rest or in motion, it will stay at rest or in motion until an external force is applied. Newton's first law of motion is also known as the inertial law. 98. The centripetal force required to keep a mass of 5 kg turning in a circular path of 2 meters radius while moving at 10 meters per second is. So we have the mass equals 5 kg. We have the radius r equals 2 meters. And we have the velocity at which the object or the mass is moving, that is 10 meters per second. The formula for the centripetal force equals mv squared over r. So you substitute the values. So we have the mass to be 5 times 10 squared divided by 2. That is going to give us 5 times 100 divided by 2. 500 divided by 2 equals 250 newtons. Right there. An aircraft of mass 1 ton is accelerating at 10 meters per second. The engine exerts a total thrust of 70 kilonewtons. The drag force exerted on the aircraft is. So you have the mass. The mass m equals 1 ton. That is 1,000 of a kilogram. The engine, you have the acceleration. So when you look at the question carefully, the unit for acceleration was wrong. It's supposed to be 10 meters per second squared. So acceleration equals 10 meters per second squared. The engine exerts a total thrust. So that's the F thrust. F thrust equals 70 kilonewtons. The drag force exerted on the aircraft is, so you need a force of drag, or the drag force. So using the formula, the net force of an aircraft, equals the thrust force minus the drag force. Right, so the net force, that's the mass times the acceleration. That was going to be 1,000 kilogram times 10 equals to 70 kilonewtons minus the drag force. 1,000 times 10 is 10,000. That will be 10 kilonewtons equals 70 kilonewtons minus F drag. F drag equals 70 minus 10 kilonewtons. That will be 60 kilonewtons. Velocity is a vector quantity. So that is the end of the part 2 of the kinetics, part 66, module 2, physics. Stay safe keep learning, keep reading. See you soon.